Hello grade 12 American System, this is Mrs. Nancy. Today I'm going to start a new section 22.3 Isomers. The objectives of this section are: explain how the properties of constitutional isomers differ and identify the two types of stereoisomers. So please open your book page 775. Look at the structural formulas for butane and 2-methylpropane. Even though both compounds have the formula C4H10, their boiling points and other properties differ. Because the structures are different, they are different substances. So compounds that have the same molecular formula but different molecular structures are called isomers. So butane and 2-methylpropane represent a category of isomers called constitutional isomers. Constitutional isomers are compounds that have the same molecular formula, but the atoms are joined together differently. So they differ in physical properties such as boiling point and melting point. In general, the more highly branched the hydrocarbon, the lower the boiling point of the isomer will be compared with less branched isomers. Stereoisomers. Stereoisomers are molecules in which the atoms are joined in the same order, but the positions of the atoms in space are different. The two types of stereoisomers are cis-trans isomers and enantiomers. Cis-trans isomers have atoms joined in the same order, but the spatial orientation of the groups differs. So, in the cis configuration, similar groups are on the same side of the double bond, but when similar groups extend from opposite sides of the double bond, the isomer is in the trans configuration. Cis-trans isomers have different physical and chemical properties. A carbon with four different groups or groups attached is an asymmetric carbon. Pairs of molecules that are mirror images and not superimposable are called enantiomers. So let's start sample problem 22.4. Which compound has an asymmetric carbon? Part A. The central carbon in compound A has two CH3 groups attached, so the carbon is not asymmetric. Part B. There are four different groups attached to the central carbon, so compound B has an asymmetric carbon. Number 19. Identify the asymmetric carbon, if any, in each of the following compounds. So, part A. There are four groups attached to the central carbon, so the carbon is asymmetric. Part B, there are two CH3 groups attached, so the carbon is not asymmetric. Number 20. Identify any asymmetric carbons in the following compounds. Part A. The carbon has different groups attached, so it is an asymmetric carbon. While part B, the central carbon has two hydrogens and two chlorine attached, so the carbon is not asymmetric.